You probably have a 4K camera sitting in your pocket right now, you know?
Yeah.
It takes amazing video. It's incredibly lightweight, and it essentially came for free with your phone.
Yeah, exactly.
But today, we're doing a deep dive into a piece of professional broadcast equipment. Specifically, we're looking at Bolin's technical documentation for the Bolin Technology R9-418FW fast HEVC 4K PTZ camera. Our mission is to figure out why broadcasters pay a massive premium like almost $6,000 for these robotic eyes.
Instead of just using the 4K sensors we already have everywhere, right?
Right. Okay, let's unpack this. What separates a professional rig from consumer tech?
Well, to understand that price tag, you really have to look at the physical muscle of the machine. The optics are just in a completely different universe. I mean, it's built around a 1-inch Exmor RCMOS Sony image block.
Let's translate that for a second. A 1-inch sensor is massive compared to a smartphone, meaning it pulls in significantly more light.
Oh, absolutely massive.
I saw in the source specs you can shoot in environments down to 0.000008 lux.
Which is practically pitch black. So if the stage lights suddenly fail at a concert or, you're capturing a really dark theatrical performance, this camera is still delivering a broadcast clean image.
Without that heavy graininess you'd get on a consumer device.
Exactly.
Right.
Plus, it has an 18x optical zoom and optical image stabilization. That is crucial if it's mounted on a vibrating truss above an arena, for example.
And it's not just handling video, right? It has balanced XLR audio inputs with phantom power.
Right, the phantom power is a huge deal.
Because that means it sends electrical power directly up the mic cable, letting you plug professional studio mics straight into the camera.
Without needing a separate external power supply?
Right. But what's fascinating here is the camera's true tri-output feature. In live broadcasting, you never just send video to a single destination.
Oh, for sure. You have screens everywhere.
Exactly. Broadcasters desperately need different formats simultaneously for different applications. This camera can actually output independent video streams via SDI, HDMI, and IP networks, all at the exact same time. So what does this all mean for the internal processing? It feels less like a Swiss Army knife where you use one tool at a time, and more like having 3 separate nervous systems in one body.
That is a perfect analogy.
Because processing an SDI feed for the control room, an HDMI feed for a studio monitor, and an IP stream directly to a web server simultaneously must require an immense amount of bandwidth.
And doing all that without dropping a single frame requires a staggering amount of processing power. The camera is basically doing the job of an external video router internally.
With zero lag.
With zero lag, yeah.
Okay, so the hardware handles the heavy lifting of capturing the image, the audio, and distributing the feeds. But in a modern live broadcast with, say, virtual reality sets, a great image just isn't enough anymore.
No, not at all.
The production software needs to know exactly where that camera is looking at all times. Here's where it gets really interesting.
It really does. That brings us to its digital brain, specifically its integration of the Freed protocol.
Which is an industry standard, right?
Yeah, Freed is the standard. It feeds precise real-time access data back to the production software. It basically tells the system exactly where the camera's pointing, along with its pan, tilt, and zoom position.
Wait, let me push back on that.
Sure.
If it's just sending access data, isn't it still basically a static camera spitting out numbers? Like, how does feeding positional data to a computer replace the fluidity of a human camera operator following a moving subject?
Because it's a two-way street when you pair it with automation software, and the key there is the ultra-low latency. It's not just reporting where it is.
Okay, what else does it do?
It's allowing the system to lock virtual graphics to the physical space perfectly. If the camera pans left, the virtual 3D news dust pans left in exact sync.
Oh, wow, I see.
Yeah, if we connect this to the bigger picture, you're combining the camera's robotic tracking capabilities with software that can automate those complex, fluid movements. It essentially acts as an intelligent operator that never misses a cue.
Enabling spectacular VR and AR live video production. That really changes how you look at the media you consume. The next time you're watching a seamlessly produced live event or a news broadcast with floating AR graphics perfectly anchored to the floor, remember you are likely witnessing the invisible work of automated, multi-output PTZ technology just like this.
Yeah, the heavy lifting is all happening quietly in the background, usually by a robotic eye on the wall.
Which leaves us with a provocative thought to ponder. If protocols like Freed are essentially turning cameras into fully automated, intelligent operators that communicate directly with virtual sets, what happens to the human element of cinematography in live broadcasts?
That is the million-dollar question.
Right. Could a fully AI-driven system eventually direct and operate the entire show, leaving the 4K camera in your pocket as the only one still held by a human? Something to explore on your own.